All right, ladies and gentlemen, welcome after the break, and we come to, again with a second lightning talk. The second speaker would be Jacek Góra. Jacek is one of the, as he called himself, dinosaurs of Nokia in Wrocław. He started in early LT days, continued with research, technology development, and architecture throughout 5G ramp-up. Now Jacek is leading Nokia latest radio product platform in R&D. In his free time, Jacek likes to do embedded electronic projects and travel, and especially enjoying mountain hikes, which you can see right now or pretty soon on the screen, when Jacek is in Karkonosze enjoying his mountain hike. So without further ado, I give you Jacek Góra, Power of Energy Efficiency. Big round of applause.
Thank you. Thank you for the nice introduction. Good afternoon, everybody. I'm really pleased and surprised positively that so many of you wanted to come to this presentation during a lunch break. I hope you will not regret that in a couple of minutes. Just for the very beginning, one sentence. So the work that I will be presenting has been part of our activities we do in Nokia under NCBR founding, and energy efficiency is recently one of the very important requirements, very important KPIs for our products. And without spending much time on the agenda, I will jump directly to the numbers. Well, a number of surveys that have been conducted by independent industry organizations, such as, for example, GSMA, has shown that on average, 75% of power consumption of a mobile network is consumed by radio access port. And out of this 75%, roughly half, so around 40–50% of that, is consumed by the radio devices. So the radio access points that you can see on the rooftops, on the masts. And considering that in a country like Poland, there can be several thousands of radio access points, you can imagine that we have a huge opportunity to have really a huge impact on the overall network carbon footprint and also on the budget of our customers by optimizing and reducing power consumption of our 5G radios. So in Nokia R&D, in our radio department, we take the energy efficiency as one of the key requirements for the products. It has also secondary benefits, because when we decrease the power consumption of the radio is also heating up less, so we can have smaller coolers, the mass, the size of the radio is also reduced, so there are also many secondary benefits. But how can we improve energy efficiency of a device like a 5G radio? So we take two approaches, or we attack the problems from two angles. So first of all, we need to reduce the overall maximum power consumption of the radio. And this is primarily a task for our hardware engineers. Our hardware engineers need to figure out some clever ideas how to improve energy efficiency of power supply units, power amplifiers, and other high-frequency RF components. But then the survey which I mentioned earlier is also giving us an interesting information. It is telling us that typically in a mobile network, 70% of radio resources is not utilized. This means that a typical radio is operating in medium or low traffic conditions. This is the space which we can exploit by new microchip technologies and also by inventive software features. Ideally, what we want to achieve is we want to exploit this domain of low and medium traffic load to achieve a proportional curve of power consumption versus load. So looking on this graph, which you see right now on the screen, we want to make the curve linear and then maximally reduce the left-hand side, such that basically when there is no traffic going to the radio consumes virtually zero power. I will not spend much time on the microchip technology, but I will just mention that this is a key task for our system-on-chip designers and software architects, software engineers to work very closely together on the SoC design phase in such a way that, first of all, the microchip, the system-on-chip, includes the needed accelerators, the needed computing engines, such to enable the software to execute all the computing algorithms in a very efficient way. And then secondly, the microchip, the SoC, needs to include a number of solutions that will enable powering down individual processing blocks inside the chip proportionally to the computing load. And if we have this kind of functionalities inside of the chip, inside of the device that is the heart of our product, then software has a lot of opportunities to exploit those capabilities. Now, I will focus on the software features, and I will go through several examples of energy efficiency software features that our teams have been developing in the recent years, and also one feature which is under development still this year. And I will start with so-called micro DTX, micro discontinuous transmission. So radio can autonomously detect when there is no traffic being sent through the data path. And when the radio detects that, it can power down some elements of the hardware equipment in order to reduce the power consumption. There are, however, two challenges with this approach. The first challenge is that the radio, since it's making the decision autonomously to power down, it needs to be able to go to the full operation in virtually zero time. This means that there are only few hardware components, very, very selected hardware components that can be powered down in this way. Basically, this comes down to any hardware component that doesn't need to have any initialization procedure. And then secondly, the second challenge here is that when there's even a smallest amount of traffic going through the radio needs to support it with full capability. So smallest amount of traffic means the radio cannot go into this micro DTX state. The second challenge can be partially mitigated by employing packet schedulers we have in layer 2 of 5G or LTE networks. The packet scheduler can group user transmissions into chunks and then transmit this in bursts such that the radio has more opportunities to go into this micro DTX state, and with that, reduce the power consumption. A second approach relies more on analyzing and detecting longer-term trends in the network. So in every network, we have cycles, like, for example, during the night, when there is less active users, when the users are sending, receiving less data. If the network detects that it's entering this kind of phase of lower traffic, it can instruct the radios to reduce its capacity. And by reducing the capacity, I mean that the radio can switch to utilizing less frequency bandwidth, or it can use less antenna ports, such that it can support less traffic. But we use this method when there is less traffic to be carried. And in this case, the radio doesn't make the decision autonomously. Since certain analysis and awareness of the traffic trends in the network is needed, our radios are collaborating with machine learning, AI algorithms that are operating on the network level, that are detecting the trends, that are monitoring activity of users, and in this way, by collaboration of our radio device on the physical layer and then the higher management layers in the network, we can overall decrease the power consumption of the whole network without significantly impacting the network-wide KPIs. And finally, the last method which I want to mention today is the deep sleep or extreme deep sleep. So again, this is a method in which radio cannot go into deep sleep autonomously. In this case, we can achieve the highest level of power reduction by virtually powering down almost all the hardware components we have on the radio. There are only very few components that are remained powered on. But the penalty here is that we have longer wake-up time. So the radio needs time at the level of tens of seconds or a couple of minutes even with the most extreme deep sleep solution to be fully operational. So again, we rely here on network-wide monitoring of user activity, on AI algorithms that are monitoring if there is a user coming to the area supported by a given radio. And then it can, in advance, trigger radio to wake up. But okay, those are some of the ideas how we can decrease the power consumption of our 5G radios. Now, how does it look in practice? So last year, we've released Hubrock. Hubrock is the latest generation of Nokia 5G radios. And already with the first deployments, with the first customers, we were able to prove that our latest generation of products can achieve between 40 to 50% power reduction compared to similar products of the previous generation. 40 to 50% when in terms of watts means few hundred watts, at the level of 500 watts more or less of saving per each device. And then if you multiply this by the tens or several thousands of radios we have across a country like Poland, then it goes into megawatts of savings. Then this year, we continue the improvements by introducing this extreme deep sleep feature, which I explained a moment ago. And with the extreme deep sleep in our internal tests, we already see that we have a potential to reduce the power consumption even to 95% in the idle state compared to the situation without this extreme deep sleep. So to sum up, energy efficiency is one of the most important parameters for our products, as agreed by both our customers and Nokia R&D. It has many benefits for the end customer, and we need to attack the problem from all possible angles, from both hardware and software optimization. And when we introduce software energy efficiency features, then there is only, let's say, so much we can do by the radio itself. We need to exploit also radio as part of the overall system. And here we have also a huge opportunity with smart management solutions utilizing AI and machine learning to, again, monitor the trends that are present in the network and to improve quality service while at the same time reducing energy. Okay, with this slide, I would like to finish. Thank you very much. And if there is some questions, I'm happy to.
Thank you, Jacek, and big round of applause for the presentation. And as Jacek mentioned, if you have any questions, please go ahead. I can see someone very eager in here already.
Thank you. You had a slide with graph about Hubrock 64 with the power consumption. And if it's not a secret, what are absolute values for power consumption? Like how much does it take power, like in maximum traffic and in minimum?
So in the, I think it's not a secret. I will not give you exact numbers, but in with maximum load, it goes above 1,000 watts. Right, and with extreme deep sleep, we can go down to a range of 10 to 20 watts.
Wow. Thank you.
All right, thank you. Any other questions? Do we have one upstairs?
Thank you for a great talk. Is the extreme deep sleep wake up a gradual process with gradually increasing capacities, or does it just have a delay time and then is back at full force?
In extreme deep sleep, we are basically powering down virtually all the processing capabilities, including the processor. So the operating system is down, so we need to make a full startup procedure for the radio. So like system boot up time takes those couple of minutes.
And would that affect like a public emergency broadcast system? I don't know how it's called in Poland, but if the government decides to make like a weather warning or something?
That's exactly what I had in mind, that we need to rely on network-wide management and optimization. We need to have higher layers of the system to ensure that we have the minimum level of service available, even if this particular radio is powered down. Typically, the network is designed and deployed with multiple layers. So we have different technologies. We have 5G, LTE, 3G working in parallel. And the main purpose of 5G in most of the deployments is to increase the capacity. And then we have the other technologies providing the coverage, right? So in this particular case, to secure this most critical services, as you mentioned, then we can either rely on the other technologies, on the additional layers of the network, or then the network management system needs to assure that there is some backup coverage in a given area.
Thank you.
All right, thank you. Any further questions? I see none. Therefore, thank you very much again. And
Thank
big
you.
round of applause again to Jacek.